See, just have a look here. What is, because this question is what? Why it is little bit different, this question? Because they have given us what here? Spade type rudder. What they have given us, sir? Here? Spade type rudder.
Spade type.
And what is the meaning of spade type rudder? Spade type rudder means what? It is supported at what? What is meant by spade type rudder? Spade type rudder means what? Here. There is only supported at what? A rudder head bearing. We will have a what? Rudder like this. Okay. So you got it? Spade type rudder means what?
Yes.
Okay. So this is what our spade type rudder in this question. That is the only thing here we have. And here, instead of rectangular here, we don't have a rudder rectangular. Here width is changing here throughout. What is happening? Width is changing. Means from the top means at the top, just have a look here. What is the width at the top? 2.1, then again 2.05, then 1.8, 1.45, 1 meter. Okay, you got this point. So we will get a rudder drawing like this.
Yeah.
So this is what our spade type rudder drawing. You got this point?
Yeah.
So before going further, take a snapshot of this drawing. Just take a snapshot of this drawing.
Yeah. Take a note.
Okay. See, whenever we have a spade type rudder, what we need? In A part, what they are asking, in this question, what they are asking us? Diameter of the rudder stroke. What they are asking us?
Diameter of rudder stroke.
Diameter of the rudder stroke. And for this spade type rudder, what is the relation of diameter of the rudder stroke? I have given to you 16 TE divided by pi tau max. What is the relation of diameter of the rudder stroke? 16 TE divided by pi tau max. And what is meant by T? T stand for what? What is meant by T? T means what? Equivalent torque. What is meant by T?
Equivalent torque.
Equivalent torque. And that equivalent torque T will be equal to what? M plus under root of M square plus T square. Okay. So these things I have explained already in the theory. In the theory lecture, just go through that theory lecture. So here, by using this relation, you will get a T. So you have to calculate T by yourself. And how to get a here? M means what? Bending moment.
Bending moment.
And T means what? A torque or twisting moment.
Twisting moment. Yeah.
So now how to get a T? What is the relation of T we have seen? What is the relation of T we have seen? T is equal to Fn into B.
Yes.
And M is equal to what? Fn into A.
Fn into A.
Fn into A. I will explain you what is the meaning of Fn into A. So, but before that, just have a look here in this drawing. See.
Yes.
A.
Center of effect.
Center of effort, distance between center of effort and this rudder head bearing. Here we will have a rudder head bearing. Okay, that distance will be our A. So so we need a A. For what purpose we need a A? For what purpose we need a A? To get the value of what? Bending moment. M. Fn into A. You got my point? Fn into A. So yes. How to get the value of A? Tell me. A will be equal to what? See, in the question, if you read the question, the top of the rudder is 0.4 meter from 0.4 meter from where? From the rudder head bearing. From bearing. Okay, from bearing. So this distance 0.4. Okay, you are getting my point. So center of effort is nothing but what? Centroid of the rudder. Basically, center of effort is what? Tell me. Center of effort is what? Rudder. So now we need this position from the what? We need this position YC from the top. So A will be equal to what? If you observe this drawing, A will be equal to what? 0.4 plus YC?
Yes.
0.4 plus what? YC. So we need a what? To get a M. Just observe. To get a M, we need a Fn and A. A. And A will be equal to what? Small a will be equal to what? 0.4 plus YC? You got this point? So now what is unknown here? To get the value of A, what is unknown here? What is unknown here?
That centroid to the top of the rudder.
Distance between centroid means center of effort and YC. We will see how to get a YC. And here in the question, if you read, the center of effort of the can be taken as act in normal to this act as a vertical centroid of the rudder, means center of effort is a centroid of the rudder and it is 0.15 meter from the axis of rotation. So yes. B they have given us directly. What they have given us? B. They have given us what?
They have given B. Okay.
They have given us a B directly. So now tell me. So B they have given us Okay, so now here we need a what? Fn. We need a A, and B is already to us. Okay.
Yeah.
So just have a look at this drawing. So here, see what is meant by H. H means what? Here 2.1, 2. So it is at equidistance now. All this, see in the, if you read the question, what they said, a spade type rudder supported only at the rudder head has a depth. Total depth is how much? Total depth. You got the meaning of total depth? From the top to the bottom, total depth is 3.6 meter.
3.6, yes.
With the following widths at equal interval commencing from the top. Means equal interval means what? From here to here, this distance will be what? 0.9, then 0.9,
Yeah.
0.9, 0.9. There will be total. Getting my point?
Yeah, correct. So that is the interval.
That is interval, and that interval means what for us? H.
H.
H. You got me point?
Yeah, okay. So
That will be what? Our H. You got it, this H? How we got it H?
understood. Yeah. So number of intervals, okay.
Okay. Means
Total
distance
height
between
divided
two
by
intervals, sir.
distance between the two intervals.
Means this one H, small h. This distance. You got the point? What is the meaning of H?
Yes, understood.
So 3.6 divided by 4. And total how many widths here we have at equal intervals? Total 5 widths.
1, 2, 3, 4.
0, 1, 2, 3, 4, 5.
Okay, 0.
We started numbering from what? 0. Have you done programming any time?
No.
Okay, leave it. Okay. Otherwise, I will tell you that one, but you have not done programming, na? Okay. So,
Divided by 4,
okay, you got it. This 4 part will become this part 1 part. So 0, 1, 2. So distance between two widths.
Okay.
You got my point. This distance.
Yeah.
So you got it H. Now here what we have? Section, width, Simpson's multiplier. If you remember, I told you we always start Simpson's multiplier. Here we will have a total 5 sections, and section numbering will start from 0. 0, 1, 2, 3, 4. Basically 5 sections, but we start numbering from where? 0, 1, 2, 3. At a 0 section, width 2.1, 2.05, 1.8, 1.45 and 1. Simpson's multiplier here we have what? 1, 1. Okay. If you remember our discussion, we have seen, means start 1, end 1.
End 1, yeah.
Second 4, second last 4, and then in between,
and then in the
2, 4, 2, 4, 2, 4 like that.
2, 4, yeah.
But here we have only one thing, so here we will have a 2. So width into Simpson's multiplier will become our f of a.
F of a.
Okay, you got my point?
Yes, got it. Yeah.
Width into Simpson's multiplier will become what? Our f of a. This one, see this one, and then here we will do this one, and then we will have what? Summation of f of a. If you add this 2.1, 8.2, 3.6, 5.81, we will get a what? Summation of what?
Summation of f of a.
Summation of f of a. Then we will have what? Lever. Lever means what? Just distance from the top. So just basically this distance is what? 0. Then 1. Just we are assuming 1, 0 to 2, 0 to 3 and 0 to 4. You are getting my point? So here at the section 1, from the top distance will become what? Lever will become what? 0.
0.
1, 2,
1, 2, 3,
4. Basically here H will also be there. Here H will also.
Yeah.
0H, 1H, 2H, 3H, 4H means what? Distance from the top for this section 1. How much? How much this distance? Distance between section 0 and section 1. Tell me how much will be this distance?
Yeah. So
How?
that is now 0.9.
0.9 means 0.9 means what? H. Then distance between 0 and 2. How much? 1.8 or
Yeah, 1.8.
2 times 0.9? 2 times 0.9.
Understood.
Distance between 0 and 3. How much? 3 times 0.9.
3 times 0.9. Yeah.
And distance between 0 and 4. How much? Section 4. 4 times 0.9.
Yeah.
But to make the thing simple, we have omitted that 0.9. We omitted that our H. This we have not. Okay. To make the thing simple, and we will add H later. So this one.
Okay.
So f of m. Moment means what? Area into distance. This one. So f of a moment will be what? F of m will be what? F of a into lever. Okay. You got this point?
Yeah.
F of a into lever. So 2.1 into 0. So 2.1 f of a into, see same. then we will get a summation of f of a. Any doubt in this table? Tell me.
No, sir.
Okay, so you have taken the snapshot of this drawing na earlier.
1 minute.
One minute.
Yeah, I have taken. Yeah, I have taken it. Okay.
You have taken the
Yeah,
snapshot
done.
of this drawing na.
Yeah, drawing taken. Yeah.
Okay, after this snapshot, just take up this snapshot, sir.
Okay, I've taken now.
Okay, because this drawing will explain you.
Mm-hmm.
Okay, this table, you got the meaning of h, you got the meaning
Yes.
of f of a, you got the meaning of lever. How we got it lever? Here basically 0h, 1h, 2h, 3h, 4h. But to make the thing simple, here we are not considering that h. What we are doing, sir?
Mm-hmm.
We are not considering that h. Okay, and then here we got it summation of f of m. If you add this one, and then area will be equal to what? What will be the relation of area? You have to memorize this relation, that is Simpson's rule relation. 1 by 3h summation of f of a. H we have already 0.9. So we will get the area. How to get a YC? Summation of, you have to memorize this relation also. Summation of f of m into h into summation of f of a. We will get a YC. You are getting this point?
Yes.
Okay. This
Area.
area and YC. And why we need a YC? What is the purpose of YC? To get the small a.
To get the small.
And from with the help of small a, what we will get? We will get a bending moment m. What we will get, sir? We will get a what? Bending moment m. Okay, getting my point? Then we have a, now why we need a area? To get the Fn, sir. Why we need a area?
To get Fn.
Okay, because relation of Fn is what? 18 times v square into alpha, sir.
Mm-hmm.
Okay, we get a Fn, then we will have a small a, 0.4 YC. Take a snapshot of this one, sir.
Okay, taken.
Okay, so you got it. So we calculated area, then we calculated YC, then we have V, then we will get a Fn with the help of this relation. Here we have already got area with that one. You have to put this one, you have to do calculation. Here calculations are missing.
Okay.
Okay, then we will get a small a. Here we got a small a 2 meter. Then we will get a moment m, that is in Newton meter. Then we will get a torque. Then we will get a equivalent torque. And then at the end we will get a diameter.
Okay.
You got this point now?
This one, I'll complete later.
Okay, you can complete this one. So up to what point you have taken snapshot? Up to Fn, na?
I have to take the bottom part.
So now take a snapshot of this remaining discussion.
Yeah, taken.
Any doubt in this one, sir? You got it now?
Yeah, I understood the majority of the thing. I'll do it on my own.
I will send you, I have recorded this one that I have explained to you.
Okay.
But before that, sir, just my suggestion for you, just go through the theory of this chapter that I have sent to you, that video.
Yeah.